Hi there, I'm Jez, or Impbox, and welcome to my NimConf 2021 talk about making a platformer in NICO with Nim, or with NICO in Nim, whatever you prefer. In this talk, we're going to learn about what NICO is. It's a game framework, a simple game framework for Nim that's inspired by Pico 8, which is a cool fantasy console that uses Lua. I don't really like using Lua, so I built this to use Nim instead. It's great for pixel art games, low resolution, piloted software rendering. It can build for Windows, Linux, and Mac, Raspberry Pi, Android, and the web via Scriptin. Maybe also for iOS, though I've never tested it. If you have a Mac and want to try it, please do and let me know how it goes. Alright, so to actually do this, we're going to install NICO using the usual way you install stuff in Nim, which is with Nimble. Install NICO, and then wait for this to complete. This can take a while on my bad internet, but hopefully it's fast for you. I've already got it installed, so I'm just going to cancel that. So now that you've installed NICO, if you run NICO boot, which is an application that comes with NICO, it can set up a new project for you. So my name is Impbox, so that's going to be my organization name. I'm going to call this app platformer, and we're going to put it in a directory called platformer. And it creates the platformer directory for us. Ready to go. There's one thing we still need to install, which is SDL2 DLL, which you can download from the SDL website, libsdl.org. And once you've done that, you should be ready to go. Just run nimble run d to run the debug version of your application. And here we have it, the beautiful basic demo app that comes with NICO, which just has the application name and flashes when you press a button on your keyboard. Alright, so now we're going to open the source for this. So we're going to our platformer source directory and open the source that we were just looking at, of the app we were just looking at. We're gonna get rid of some stuff we don't need. We don't need to load the font anymore. That's no longer necessary in new versions of NICO. So we'll just clear the screen. And so this sets the resolution and the scaling factor and whether it's full screen or not. This will be fine for our purposes. So for making a platformer, we're going to need a piece of character art, a tile map, and some tiles, some tile art, character movement logic. That should do us for our little quick game. Alright, so in order for us to get some character art, we need to create a sprite sheet. You can do that using any image editor, ideally one that can output PNGs, because that's what NICO loads. I've created one already in a sprite, but you can use whatever you want. I'm going to save this sprite sheet as platformer assets spritesheet.png. So it's a 128 by 128 image divided up into 8 by 8 tiles. So our first tile is empty. So this is tile 0, this is tile 1, this is going to be a tile for collisions that we can walk on and jump on and land on, run into the walls of. And there's going to be our beautiful character sprite. We could could add more if we wanted to animate it, but we won't have time for that in this quick talk. Alright, now we've saved our sprite sheet, we're going to load it into NICO. We're going to load it into sprite sheet slot 1, or 0 rather. Specify the file name, the size of each tile. And now that we've done that, we can test it by drawing a sprite to the screen. So we're going to draw sprite 16, which is this one. So these go up horizontally, so this will be 15, and this will be 16. And we'll draw this in roughly the center of the screen. And let's see if this works. And it does. We have our character sprite in roughly the center of the screen. And let's get a tile map with some tile art. So we have our beautiful tile sprite. We're gonna need a map though. So there's another program we can use. I use one called Tiled, which is great open source tile map software. So we can load our sprite sheet into this, and we can create a tile map and place some tiles and draw them around however we want. And I'm going to save this into a platformer assets as map.json. And now we're going to need to load our map. Load map. Slot 0. And this will be map.json. Then we need to set map. So sprite sheet defaults to 0, load map doesn't default to anything, so we need to set it. And so we clear the screen and we're drawing our sprite. So we're going to draw it. Before we draw the sprite, we're going to draw our map. Map draw. Specify how many tiles we're going to draw. 16 by 16 tiles, starting from the first ones. And we're going to draw it at the top left of the screen. Let's see how this goes. Great, so we have our tile map loaded, we have our character art, we just don't have any logic for our character or anything about our character other than drawing it. So we're going to make a type for it, character, it's going to be a ref object. And we need to store its position, its velocity, and these are going to be NICO vec types, so vectors. So we're going to use a vector 2D of integers and a vector 2 of floats. And we're also going to use a remainder of the position, which we'll use for storing the subpixel movement. So in case in a single frame you only move half a pixel, it would be 0.5, and then on the next update it would be 1, and then that will go into your integer position. And we're going to do character.draw here, and here we'll do character.update, pass in the delta time, which is the time since the last frame, and we'll define these, update, don't do anything yet, and draw, and we'll grab this. And this will set, create a global for our character. Set their initial position. And draw. That should hopefully work. And it's still pretty much the same because we haven't added any movement. Alright, so for the movement, what we're going to do is we're going to check our inputs. So if button left is held, we're going to change our velocity. And cell. And button right. So we'll find some constants. Pick some numbers out of the air. And we're going to multiply these by time, so that if we change our frame rate later on, things will still be roughly moving at the same speed. And now we want to update our position based on our velocity. So we're actually going to update the remainder of the position because that's a float. And now we need to apply this to our actual position. So amount x equals self.ram.x.int because we want the int portion. And do the same for y. And now we should be able to move our character. Yay, we can move left and right now. We haven't added any gravity yet, or jumping, and nor have we added any collision. So let's get some collision working, so we can at least stop when we hit these walls. So what I'm actually going to do is make a move x function. And a move y. We'll leave move y for now. And so what this is going to do is we're going to go self.movex and out x. So what we're going to do is we're going to move one pixel at a time. And after moving each pixel, we're going to check if we're going to check if our next pixel movement will make us run into a wall. And if we're going to hit something in that movement, we're going to stop and not move into that position. That way we don't have to worry about trying to figure out how to get back to a good position. So for we're going to figure out the number of steps, and that'll be the absolute value of the amount, and the direction, which will be the sign of the amount. And for and it's actually going to be our inlet next. Pause equals pause plus. And then if next pause is not hitting anything, we're going to set our x to next pause.x. That's fine too. They'd be doing pretty much the same thing. So how do we tell if we're going to hit something at our new position? So if self.would hit wall at next pause. So we're going to have to check our tile map to see if any of the tiles that we're going to be moving into will be solid. What we can do, we have a function called mget, which is our map get, and takes tile coordinates and will return the tile number. So if we look at our tile map, so this is going to be tile 0, this is going to be tile 1. So if tile equals 1, then we would hit something. So we just need to figure out what these numbers are. So we can say next pause. So the tile coordinates, not our, are going to be, this is going to be 0, 0, this is going to be 1, 0, and so on. So each of these are 8 by 8. So we can go x divided by tile size, which will be 8. Y as well. And this, if we would hit wall, then we actually don't want to update the position. We want to break. And we want to set our velocity to 0. And set the remainder in that to 0. And only do this if we wouldn't hit the wall. So now, if we test this, we will hopefully, no, we won't compile. Amount y is not defined, because this is just called amount. We'll fix up the move y function in a moment. We can just copy and paste from movex. We stop, but in the wrong spot, because our current tx, ty is just for the new top left of our character, a single pixel. So this would work fine if our character was only a single pixel. But our character has 8 by 8 pixels, so we need to check multiple spots. So min x equals next pause dot x. So we'll figure out the bounds of our character. So if we're a 8 by 8 tile, we can figure out the min and max coordinates, and then we can do this for all of the tiles that we'll cover. So we'll figure out these same numbers, we'll convert these to tile coordinates. So I'm using T to signify that's a tile. Alright, so, and now if we loop through all the tiles, and go to this. This should check for all the tiles that our character will be overlapping. And now we run into the walls correctly. Alright, so now that that's working for X, we should be able to copy this for Y. That looks right. And now if we add some gravity, say self.y plus equals gravity. Equals other random number. Our character falls and lands. We have no way to get back up. So let's add a jump. I'm going to use an int to store this for certain reasons. So if button P for pressed, so when the button is pressed, it's the A button on a gamepad or whatever. Jumping equals 0, 1. And we'll apply some velocity in Y. So negative will be upwards. So jump and out. It's not constant. And let's see what happens now. Yay, we can launch ourselves into the air. So if we hold the button down, so yeah, every time we press the button, regardless of whether we're touching the ground, we keep jumping up. So we need to only allow jumping if we're actually on the ground. So if and so when our move Y hits hits the wall, and we're going, if our direction was greater than 0, which means we were going down, then dot on ground equals true. So, and on ground. So now we can only jump again once we touch the ground. We can still jump if we fall off a ledge. So if we don't, basically if move Y doesn't hit something, we're not on the ground, so we can say so now we can no longer jump when we fall off, but looks like we can't also jump because we may not have moved a pixel. So we probably only want to do this if we move a pixel and don't hit anything. So now we can jump when we're on the ground, and we can't jump when we're not on the ground. And we keep sliding forever because we haven't implemented any friction or braking. So what we can do, we can just reduce our velocity a bit. There's better ways to do this, but at least now we'll stop. And we have the basics of a platformer. could make it feel a lot better by tweaking a bunch of these constants. But it's all you really need to get started with making a platformer. And you can have lots of fun coming up with lots of different numbers to see how it feels. Make lots of different types of tiles. Yeah, and then get into fun extra things like adding slopes or ladders. Maybe I'll do some more tutorials about making a more complicated platform in the future. But that's it for now. Thanks so much. Hope you enjoyed the talk, and if you've got any questions, dump them in the chat, and you probably already have. Hopefully see you in the Nim Discord. There's a game dev channel which is really good, so you should join that and talk about making games with us. Thanks very much. Chat to you later.